Hi folks, until we can be together again, this chapter 6 has a lot of really cool stuff in it. It's kind of one of the chapters I was looking forward to exploring with you this year, but we're not together right now. So I'm going to skip around a little bit in this chapter and we'll do the kind of simple, boring stuff while I am not with you. And that's going to bring us to lesson 6.5. It's about indirect proof and inequalities in a triangle. We're going to just mention indirect proof. Don't be afraid. And then the big kind of takeaway is about what happens with these inequality theorems, we call them, in a triangle. So an indirect proof is a way to write a proof by assuming that what you're trying to prove is true and then proving it can't be true. Here's an example. And there's lots of different ways to do proofs. There's things called proofs by induction, indirect proofs. We've done direct proofs. This indirect one, it's going to kind of make sense as we read through this question. And again, these are right from your book, these questions. I'm just following along in section 6.5. It says, write an indirect proof that in a given triangle there can be at most one right angle. So we're trying to prove that we can't have more than one right angle within a triangle. Our given is that we have this triangle called ABC, and we're trying to prove, again, that it can have at most no more than one right angle. So with an indirect proof, what we do is we assume that the opposite of what we're trying to prove is true. So we're going to assume that triangle ABC has two right angles. So we assume the negation, sort of, or the opposite, the inverse of what we're trying to prove. And then you can kind of see where this is going. If we assume temporarily that ABC has two right angles, we'll assume, let's say, A and B are both right angles. But by definition, angle A and angle B would be 90 degrees, and by the triangle sum theorem, A plus B plus C has to be equal to 180. And using that substitution idea, we can see if we have two right angles, already we've used up 180 degrees. Therefore, the other angle would have to be 0 degrees, and we can't have an angle of 0 degrees. So this contradicts that given information, the given information that we had assumed to be true. And that's called a proof by contradiction. I mentioned this in Algebra 1. Sometimes we use this symbol to represent a contradiction. And that's it. So we assume the opposite of what we're trying to prove and then prove that that can't be true. So then what we're trying to prove has to be true. Proof by contradiction. Or what we call an indirect proof. So we proved indirectly that a triangle has to have at most one right angle. All right, the better stuff in this chapter. We're talking about relating the length of a side to an angle measure. You probably have a pretty good understanding of what this means. They've asked you to do this little activity here. Draw an obtuse scalene triangle, label the largest angle on the longest side, label the smallest angle on the shortest side. What do you notice? Well, again, something you probably have an intuitive understanding for, that the longest side happens to be opposite the largest angle, and the smallest side happens to be opposite the shortest side. Keeping in mind, when we talk opposite sides and angles, we're talking about if I draw a line from that vertex to the side that's opposite it. So not the sides that make up the angle, the side that is opposite that angle. Okay, and that's important notation for us. So we end up with two theorems out of this idea, and again, kind of obvious theorems. The first one is the triangle longer side theorem, which is kind of an awkward name for a theorem, but that's okay. It says that if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So we've got the longer side here, and the shorter side here. That means the angle opposite, in this case, opposite the 8, the angle opposite the 8, angle C, and the angle opposite side 5, angle A, are related so that C is larger than A because the side made up of AB is longer than the side made up of BC. And kind of the opposite of that is true. If one angle is larger than another, then the side opposite will be longer than the side opposite, the smaller angle. So we've got a 50-degree angle and we've got a 30-degree angle. The side opposite the 50-degree angle, that side BC, will be longer than the side opposite the 30-degree angle, that side AB. Okay, so pretty obvious, but we do have theorems that state that. There are some tools. There's a Desmos tool in that website, on that web page, that allows you to check in with Desmos and run through kind of an activity that shows you and leads you through these theorems. I do want to point out to you, I think I mentioned this earlier in the year, but if you go to bigideasmath.com, and you might see this part of it first, but if you scroll down, you'll see this easy access materials. This is the kind of the digital version of your textbook. If you choose Geometry and Massachusetts and click on the easy access book, you should be able to see your textbook. And for some reason right now I'm not able to run through the table of contents, but the reason I bring that up is because, so what does that triangle inequality theorem do? Well, it lets us be archaeologists. Let's be archaeologists today. An archaeologist finds artifacts at 3 different locations. The pottery is 82 meters away from the tools and 89 meters away from the drawings. And the drawings and the tools are 96 meters apart. List the angles of that triangle in order from smallest to largest. Well, they've sketched that out for us here. We have the 89, the 82, and the 96, and it says which angle is biggest. Well, the longest side is this side, which means the largest angle should be this angle. So angle P is the largest. The shortest side is this side, which means the smallest angle should be angle D. And then the medium size, the mama bear size, would be this side. Its angle is angle T. Notice I wrote those with angles. We want to be careful. If I wrote this as an inequality, I might want to say smallest angle is angle D. Angle D is less than angle T, which is less than angle P. That's a little confusing to write that, so we might do this. Angle D is less than angle T, which is less than angle P. So be aware of the less than sign versus the inequality sign. Here's another example. Now list the sides of triangle DEF in order from shortest to longest. They've given me angle D is 51 degrees, angle E is 47 degrees. With a little arithmetic, I find out that measure of angle F is 82 degrees. And now I'm asked to put the sides in order from least to greatest. Well, the smallest side would be opposite the smallest angle. That would be opposite angle E. So that would be DF. DF is less than, the next biggest angle is angle D. Its opposite side would be EF. Is less than, the longest side would be DE. Okay, so those inequalities we can write with triangles, their angles or their sides. This is one of the big takeaways from the chapter, this triangle inequality theorem. If I gave you any lengths of sides to try to form into a triangle, not every group of 3 numbers can be formed into a triangle. If I gave you sides, if I gave you toothpicks, let's say that were 2 inches and 2 inches and 5 inches, I could not form a triangle out of those 2 triangles. If I pulled those 2 inches down and 2 inches down, there's no way for them to meet to create a triangle. If I gave you a toothpick that was 4 inches long and one that was 2 inches long and one that was 5 inches long, yes, I could make a triangle out of that, those three pieces. Or how about toothpicks that were 2 inches and 3 inches and 5 inches? I couldn't do that either, because if I tried to make them meet, they would meet exactly on that third side. So what we come up with is this idea called the triangle inequality theorem. And the triangle inequality theorem says that the sum of the lengths of any 2 sides of a triangle has to be greater than the length of the third side. So if I take the sum of, given any 2 numbers, I don't know, we'll call this one 8 and this one 3, it has to be bigger than that third side. So maybe that third side is 10, I don't know. But the sum of any 2 sides has to be bigger than the third side. Always, 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 always. Again, there's a Desmos tool here if you were in the the browser, you could see that. I think I have it saved. Let's check. All right, here we go. So my third side here is AC. You can see that's 8 units long. If I were to move, maybe I can't do this. Let's see. If I were to move point B, every single time I do that, if you check out the sum of the other two sides, this side plus this side would always be bigger than this side. Or if I look at any other pairing here, this side plus this side would have to be bigger than this side. Or which two have I not done yet? This side plus this side would have to be bigger than this side. And that makes sense to us, kind of. We don't think about it too much, but it makes sense. Otherwise, we wouldn't really have a triangle. So here's what we do with that idea of the triangle inequality. We might be told that something like a triangle has one side of side length 14 rather, and another of side length 9. Describe the possible lengths of the third side. So we don't know what the 14 and the 9 are. Let's call that third side X. We don't know what it is. And we'll draw diagrams to help us here. It's possible that the longest side is 14. It's also, and that the smallest side is X, rather. It's also possible that the longest side is X. We don't really know. What we do know is that the sum of those, any two sides, so for example, X plus the smaller side would have to be bigger than the longest side, in which case X would have to be bigger than 5. Or if that X is the longest side, then the sum of the two smaller sides, 9 plus 14, would have to be bigger than X. So X would have to be less than 23. So the possible sizes for that third side would have to be between 5 and 3. And we remember how we write that compound inequality. 5 is less than X is less than 23. And notice again, I didn't use less than or equal to. It has to be less than or greater than. It can't be equal to, otherwise we wouldn't have a triangle. And that's it for today, guys. Again, I'm going to have you do some work in your book, and just keep that work in your notebook, and we'll talk about it when we get back together. Thank you. Have a good day. And let's do page 3, 28, 5, 6, and 12 through 28 even. All right, and that's it. Bye, guys.